Hello everyone, this is Mrs. Lim and welcome back to my channel. Okay, in this video, we'll be going through chapter 8, Kinetic Particle Model of Matter, part 1. Okay, so in this part, we'll be covering the following. 8.1, how does the kinetic particle model relates to the states of matter? So we'll be covering the following. We are going to look through the properties of solid, liquid, gas, and then use the kinetic particle model to describe why does different states of matter have different physical properties, as well as what is Brownian motion. Okay. So before we start, let's do a very quick recap of what you have learned in your lower sec science. Okay, the first question, the particulate nature of matter states that matter is made up of small particles that are in constant and random motion. Okay, the answer for this is true. Okay, let me highlight for you. The answer for this is true. We learned that all matters are made of tiny particles. Okay, in lower set, you learned that we draw these tiny particles in terms of circles. Okay, they are always in constant random motion. For a solid, they will be vibrating about in their fixed position. For a liquid, they will slide past each other. And for your gas, they'll be moving about freely and randomly in all directions at high speed. Okay, so I've also answered the answer for question number 2 for you. Particles in a gas are very far apart and they move at high speed. This is true. Okay, in solid, liquid, and gas, the particles have different spacing, arrangement, as well as speed. Let's move on. Okay, so the first one, okay, that you must know the basic of this chapter is that all metals, no matter what state they are in, solid, liquid, gas, they are all made out of tiny particles. And these tiny particles are in continuous random motion. Okay, then next, okay, in this whole part, you only need to know, okay, whenever I transfer energy into a solid, liquid, or gas, the energy goes into either the internal kinetic store or the internal potential store. Okay, and similarly, if I were to remove energy from a solid, liquid, or gas, okay, I'm going to remove energy from either the kinetic store or the potential store, or from both the kinetic and potential store. Okay, so energy goes in, it goes into two parts, either KE or PE. And similarly, energy comes out, it either comes out from either the KE or PE. The KE and PE is the total amount of energy that a solid, liquid, or gas have inside them. Okay, the internal energy. Okay, so this one I will skip. Okay, I'll go directly to my summary table. You should have learned this before in your lower sec science. Okay, about, let me just close this. Okay, you should have learned this before in lower sec science about solid, liquid, gas. This table you need to memorize. You need to know that solids, in terms of arrangement, orderly and very closely packed, liquid disorderly, and still quite closely packed. And for gas, is disorderly and very far apart. Attractive forces. Solids have very strong attractive forces. Liquids have medium, and gas have very weak forces of attraction. Okay, and so therefore, gases, the particles are free to move about randomly. They have very high kinetic energy, but for solid, because they have very strong forces of attraction, the particles are held in fixed position. They can only vibrate about their fixed position and has very low kinetic energy. Okay, and for liquid, they can slide freely throughout the whole liquid. Okay, then we are going to go through this question. You may pause the video to think about the answers yourself. I'm going to go through the answer now. Okay, which is the best explanation for a solid having a fixed volume and a fixed shape? Okay, so I'm interested in fixed volume and fixed shape. Fixed volume means that I cannot be compressed. My volume is fixed. Okay, most probably because the particles are already very closely packed. Okay, so it cannot be compressed. So the answer B looks like it's correct, but it doesn't apply. Why does it have a fixed shape? Okay, it does not have any empty space, or it cannot be compressed, can only be answered for fixed volume. Okay, and closely packed is also for fixed volume. For fixed shape is because in a solid, the particles can only vibrate about their fixed position. They don't slide, they don't move freely. Okay, the particles are held in fixed position. And all of this, why is the particles in fixed position? Why is the particles closely packed and cannot be compressed, have very little empty space? Is all because they have very strong forces of attraction. Okay, so the forces of attraction is the main thing that governs most of the properties of your solid, liquid, gas. Okay, so the answer is C. Okay, let's move on. Okay, next, we'll move on into what we call a Brownian motion. Okay, in 1827, there is a scientist called Robert Brown. He started to observe under a microscope that pollen grains, okay, when they're suspended in water, they are always in constant and random motion. Okay, so he started to analyze a lot of things, and he was the one who discovered what we call the Brownian motion nowadays. Okay, so let's go in depth of what is Brownian motion. Okay, so this is Robert Brown and this is Albert Einstein. Both of them discovered the kinetic particle theory. Okay, so I'm going to play, no, I'm not going to play this video. Okay, you may play this video on your own at home. Okay, so what happens here is, I'm going to just elaborate on what you are going to see in this video. Okay, what happens is they put some smoke particles into a glass cell, which is a transparent glass container. Okay, how do I introduce the smoke particles? I just burn a piece of paper. So after I burn a piece of paper, there's smoke. I just pass all the smoke in, just collect all the smoke into this glass container. Okay, then I'm going to put this glass container under a microscope. Okay, if you know, your microscope has a very bright light source at the bottom. So light is going to shine through that glass tube or that glass container, and then you have a microscope at the top, and where your eyes will look through the microscope. Okay, why do we need a microscope? Because the smoke particles are very small, it's a bit hard to see, and the microscope gives the bright light source at the bottom. Okay, so what is observed is that you will see that there's many bright spots of light, okay, or bright points moving about randomly. Okay, there's no fixed direction that they move, but they are moving about randomly. Okay, so what is the explanation for this is happening is because inside this glass cell, there is not only smoke particles, there is also air particles surrounding them. Okay, but when you shine bright light onto it, the smoke particles, which is not transparent, okay, they will scatter the light shining onto them, so they will appear as bright points. Okay, they will reflect the light source into your eyes, so you will see the smoke particles as bright specks of light, okay, or bright dots lah, okay. And then the smoke particles move randomly, okay, they are all moving around, okay, because of there is uneven bombardment or uneven collision on different sides by the air molecules. Okay, the air molecules are inside, the air molecules are in continuous random motion. So the air molecules will continuously heat and heat and heat and heat on different sides of the smoke particles. And because of this uneven bombardment by the air molecules, the smoke particles also move in a irregular manner, or we call it the random motion. Okay, it will move in the direction of the resultant force. So maybe I have one smoke particles, it will be a drawing. Okay, so let's say I have my red color one are my smoke particles, and then my black color one is my air particles. Okay, so my air particles might hit here at one instant, and then the other air particle might also hit here, and then these smoke particles will move in the direction of the resultant force, which is here. Okay, double arrow represents the resultant force. Okay, so because of the air molecules which are constantly moving, okay, they will collide with these smoke particles, and these smoke particles move, okay, depending on where the resultant force is. But they are always hitting, and therefore the movement will be always in a random motion. Okay. Okay, just take note that Brownian motion, when we talk about Brownian motion, it's really about what we can see. Okay, we couldn't see the air particles because the air particles is transparent. When light passes through it, it will just go through it. Okay, no light will be scattered or no light will get reflected into your eyes. So you don't see the air particles, but you do see the smoke particles. The smoke particles are actually carbon particles. Okay, so you don't see the air, So the Brownian motion is not the random movement of the air particles. The Brownian motion is what you see, which is the random motion of the smoke particles when they are surrounded by air particles. Okay, so I repeat again, Brownian motion is what you can see. You can only see the smoke particles moving about, not the air particles. Okay, so Brownian motion is the random motion of the smoke particles when they are surrounded by the air molecules. Okay, similarly, Brownian motion can not only be done on smoke particles, it can also be done on pollen grains. So what happens is, similarly, pollen grains are placed in water. Pollen grains are very tiny and small. Okay, and then if you look under a microscope, you will see that the pollen grains are moving about randomly. Again, we couldn't see water molecules. Okay, but we can see the pollen grains. So the pollen grains again move because of uneven bombardment on different sites by the water molecules. Okay, and because the water molecules are in continuous random motion, they will continuously hit the pollen grains. The pollen grains will always move in the direction of the resultant force, which is random. So again, Brownian motion is the random motion of the pollen grains, not the water. And why is it that the pollen grains move in a random direction? It's because of the random motion of the water particles surrounding it. Okay, so this is a diagram of how it looks like. But whenever we draw, we don't draw like this. The diagram is not like this. Okay, so whenever we draw, how does a Brownian motion looks like? So this is the smoke particles or the pollen grain. We'll draw straight line. Okay, zigzag in any other ways. Okay, just take note that it must be in zigzag. Okay, so it's not really zigzag. Okay, and you need to have arrows on each line. Okay, any zigzag manner. Okay, straight lines with zigzag manner. Okay, so what happens is the smoke particles might hit it here and here, then it moves here because in the direction of the resultant force. Then at the next moment, it might gonna hit at here, so it move over at the other way, etc. Okay, so it will be in a zigzag moment. Okay, next. Oh, I do actually have, so I'm going to erase this. Okay, so this is how it looks like. Okay. Okay, so what are some of the factors that affects Brownian motion? We have a few factors. The temperature. It was observed that if you were to increase the temperature of either the water or the glass cell, okay, with air and smoke particles, okay, it is observed that the Brownian motion becomes more random and faster. Okay, what is happening is again, remember, it's not the smoke particles or the pollen grains that is gaining kinetic energy, is the surrounding air particles or the water particles that is gaining kinetic energy. So as temperature increase, okay, every time first step, particles will start to gain kinetic energy. And it's which particle you must mention, whether it's air, water, smoke, or pollen grains. But the movement of the smoke and pollen grains is caused by the air and water. Okay, it's not caused by the temperature. Okay, so it is the air and water particles that gain kinetic energy. They will move faster. And then what happens when they move faster, they will collide more frequently and with greater force. Okay, they have more energy. So every time they hit, it will be harder as well. Okay, and because they have more kinetic energy, they are moving faster, they will collide more often. So more bombardment or more collision and with greater force on the smoke particles, and therefore with a larger collision and larger force of collision, the resultant force on the pollen grains or the smoke particles increase, and therefore the motion increase. Okay, as well as it is also dependent on the molecular size. We say that if the size is bigger, the motion decrease. Okay, because okay, when it is bigger, okay, they are heavier. Okay, we call it, let me just jot down over here. When it's bigger, the mass increase. Okay, just take note that the force exerted by the air or water will still be the same. So with the same resultant force, okay, and then using F equals to MA, resultant force is the same, okay, because the air and the water particles does not change. It's just the smoke and the pollen grains becoming bigger, okay. The air and the water particles move at the same speed, collide with the same force, it have the same resultant force, and then with the mass increase, the acceleration will decrease, okay. So they will move slower, okay. Okay, so let's do a very, very quick recap. Okay, so what is Brownian motion? The answer is, okay, remember, it's not the movement of water, not the movement of air, because I couldn't see them. Okay, it's the movement of the pollen grains or the movement of the smoke particles. Okay, not the movement of the fluid molecules. Fluid molecules are air and water. Okay, they are fluids, anything that can flow, air and water. Okay, but it's the movement of pollen grains in water or smoke particles in air. But it is caused by, Brownian motion is caused by water molecules or air molecules. Okay, it is not caused by pollen grains and smoke, but what you observe or what is Brownian motion is smoke particles and pollen grains. Okay, then after that, draw a diagram. It should look like a zigzag line. Okay, then after that, I'll show you the answer for the zigzag line later on. As temperature increase, how would the movement of the pollen grains change? Explain your answer using the kinetic model of matter. Every time the answer asks for you explain using kinetic model of matter, you need to mention in terms of what happens to the particles. Okay, so this is the answer. So the first answer I already mentioned is C. Okay, is the random motion of the pollen grains caused by the uneven bombardment by the water molecules, which are in continuous random motion. Okay, so this is the zigzag diagram of how your pollen grains will be moving. So when the temperature increase, just take note, you must mention which particles gain kinetic energy. It's the water molecules that gains kinetic energy. So they will move faster, they will collide more often and with a greater force on the pollen grains, and therefore the pollen grains will move faster. Okay, so summary of part 1. Kinetic model of matter states that everything, solid, liquid, gas, are all made out of tiny particles that are in continuous random motion. And then the forces of attraction is mainly used to explain the different physical properties, whether it can be compressed, cannot be compressed, the type of movement that it has, etc. of your solid, liquid, gas. Okay, and the random movement of your smoke or pollen grains is called Brownian motion, and it is caused by the continuous random motion of your surrounding air or water particles. Okay, finish. That's all for part 1.